VIDVAS Learning is a product of VIDVAS Technologies Private Limited. In this session, we would go over LTE Intra MME Inter SGW X2 handover call flow.
The following is the list of widely used abbreviations in LTE EPC. The diagram shows non-roaming architecture for 3GPP access. We assume that you have fair understanding of LTE EPC architecture. If not, please go over VIDVAS Learning LTE EPC overview video tutorial.
Let us go over LTE Intra MME Inter SGW X2 handover call flow. Assume UE is attached in LTE network. UE sends RRC measurement report to ENB. Based on the signal strength received in the measurement report, source ENB decides to hand over the UE to target ENB. Assume X2 connection is available from source ENB to target ENB. Source ENB sends X2 AP handover request to target ENB. Target ENB sets up the radio bearers and sends X2 AP handover request acknowledge message to source ENB. Source ENB sends RRC connection reconfiguration message to UE, indicating to camp onto target ENB. X2 APSN status transfer is sent by source ENB to target ENB, only if at least one RLC AM bearer is accepted by the target ENB. If all bearers are RLCUM, X2 APSN status message will not be sent. If there is any uplink data or downlink data received at source ENB from the UE, or for the UE, source ENB forwards the data to target ENB by sending X2 data forwarding message. This is because handover is in progress. Target ENB takes responsibility of sending the UE data. Target ENB may buffer the data received from source ENB until it receives RRC connection reconfiguration complete message from the UE. After receiving RRC connection reconfiguration complete from UE, target ENB forwards buffer downlink data to UE, and forwards buffered uplink data to Internet via SGW and PGW. Target ENB sends S1 AP path switch request to MME, with target ENB FTE ID. In this scenario, SGW is changed as target ENB is served by different SGW. MME sends S11 create session request to target SGW. Create session request would have target ENB FTE ID for downlink path also source ENB FTE ID. Source ENB FTE ID here would be used to send S1 UN marker. Target SGW sends S5 modify bearer request to PGW, with target SGW FTE ID for downlink path. PGW sends S5 modify bearer response to target SGW. Target SGW sends S5 create session response to MME with target SGW FTE ID for uplink path. MME sends S1 AP path switch request acknowledge to target ENB. S1 AP path switch request acknowledge would have target SGW FTE ID for uplink path. Target ENB sends X2 AP UE context release to source ENB, to release UE context at source ENB. Target SGW sends S1 UN marker to source ENB. This is to inform source ENB that handover is complete, and source ENB does not need to forward data to target ENB anymore. Source ENB sends X2 UN marker to target ENB, to inform target ENB that target ENB can discard any packet that it may receive from source ENB on X2U interface. MME sends S11 delete session request message to source SGW to clean up the UE context. Source SGW sends S11 delete session response to MME. As end-to-end tunnel establishment is done, uplink path takes UE, target ENB, target SGW, and PGW.
The following is the list of 3GPP references. 3GPP 23.401 for LTE architecture. 3GPP 33.401 for security. 3GPP 24.301 for NAS. 3GPP 36.413 for S1 AP. 3GPP 36.423 for X2 AP. 3GPP 29.272 for S6A. 3GPP 29.274 for GTPC. 3GPP 29.281 for GTPU. 3GPP 29.212 for GX. 3GPP 32.299 for G and GZ. For upcoming videos, please subscribe to VIDVAS channel at the following location. For any queries, please contact us at vidvaslearning@gmail.com. To know more about VIDVAS Technologies Private Limited, please visit our website www.vidvas.com. Thank you for watching.